So this last session that we're going to get into, we're going to talk about SQL projects with the Microsoft Build SQL.
Yeah. So, hey, folks, I'm Drew Squires-Cabala. I'm a program manager here at Microsoft. Microsoft.Build.Sql is the project SDK for SQL projects. And so today we're going to take a look at that SDK and what it gives you for doing DevOps with SQL. Before I kick off, I did want to mention that everything I show today, the samples and everything, is in a public GitHub repository right now at aka.ms/SQL Projects-samples. We've been talking about .NET for the last couple of days at a really high level. I am not the .NET expert, but at a really high level, we're familiar with this project lifecycle where you take your C# project, you build it, and with that, you get your executables, your DLLs for a library. And then when you're ready to ship it, you deploy it out to an app host. So when you're developing locally, this is just your main machine. But when you're ready to ship that to Azure or to your on-prem data center, you put that on an app host. So that kind of build and deploy project lifecycle is pretty familiar to us as developers. With the SQL Projects SDK, we now have a .NET project type where the SQL code, your objects, are validated as different objects. So you could have a table and a stored procedure and then foreign keys between tables. So think of this instead of writing C# that declares classes within a namespace, you're defining the tables and the stored procedures and all those other objects within a single database. So you're working within the unit of a database. To accomplish this, there was the original SQL projects, which were previously only known as SSDT or SQL Server Data Tools. And this project SDK brings those original SQL projects all the way over to modern .NET. So this is our cross-platform support as well as adds in new features. The things that have existed since the original SQL projects are the concept of having a DAC build artifact, as well as being able to publish this, which is slightly different than when you're deploying your application code. What's special about a DAC is that it's a compiled artifact that comprises the entire database model. So it has gone through and made sure that you haven't messed up any foreign key relationships and your T-SQL syntax is all correct, because it represents what you would visualize when you connect to a database as Object Explorer. That is all contained within that DAC build artifact. What the projects SDK and for Microsoft.Build.Sql and the tooling around it also provides is not just like a DAC file, here, good luck, but a whole set of tools and this API for being able to deploy a DAC, not just to a new database, but updating existing databases. So as you do continuous development, you can modify a database that exists already by applying a DAC to it. And this is often described as declarative development, or the idea that you don't have to manage a bunch of different SQL scripts for creating a table and then altering the table and trying to remember which scripts have been deployed where. In this case, with SQL projects, all you have to worry about is developing the objects themselves, and then there's tooling to help you along the way. So where we end up with SQL projects is a very similar development lifecycle for databases, where you're building your project to a DAC, which is your database package, and then your deployment takes that and applies it to a database. So you're still building and shipping databases, very similar to your applications. If we think like bare bones, how do I get started? You need two things. Really the main one is going to be your SqlPackage CLI. This is available as a .NET tool. You can install it and immediately get it on your path using the .NET tool install command with the global flag. The other thing that can be really helpful for starting from the ground up are the SQL Projects templates. These take place of using Visual Studio or VS Code to create a new project. You can do this just from the command line, and then that sets up your SQL project. Everything else you do either is going to be using the SqlPackage CLI or is using .NET commands like .NET build. The thing that I want to kind of pause and remind us here is it's great that everything else is .NET, because if you're a .NET developer, you're familiar with it, you've already got the .NET SDK installed. The thing that doesn't mean is that if you're not a .NET developer, or if you have additional projects in your organization that use Python or Node, Those can also use SQL projects to manage the database state because all you need is the .NET SDK to run the build on the project. So getting started with SQL projects, you can work from a new database. That's kind of intuitive. But what also needs to be reminded of everyone is that you can start from an existing database. Just because the project has already started, maybe you're using an ORM like EF Core to create your database object. Now you want to have those objects under source control or be able to manage the deployments more. You can do this by either using some of the tooling where there's a menu item, usually like create project from existing database, or we can even use the SqlPackage CLI to extract the database out to individual projects. So I've got a couple of recorded demos today because you never know when things might go wrong. But with that, from this first demo, we're just going to pop into Visual Studio. This is 17.12, which released earlier this week, where the SDK-style SQL projects are currently available in preview. When I create a new project, I'm getting that SDK-style SQL project, and it'll work with your modern .NET SDKs. But what's really important, especially for people that are familiar with the original style SQL projects, is when you edit the SQL file or look at it, it's going to look really different because it's way less verbose. You don't have individual files listed in this project file. If you've only ever been using SDK style projects for C# projects, you don't appreciate that, and that's totally fine. This is how it should be. I also have SqlPackage already installed on this machine. So what I'm going to do is I'm going to connect to an existing database. I have the connection string for it, and I'm going to use the extract command. With the extract command, I'm able to get all of the object definitions out into individual SQL files. So I'm going to grab the connection string, and it's going to use interactive Active Directory authentication. So I'm not, storing passwords right now, but I'm going to go ahead and authenticate in the browser when this runs. When I extract and use the extract target schema object type, that last property on the end, it's going to organize the objects by schema and by object type in different folders. It makes it easier to sort through, especially when you have tons and tons of objects coming in individual files. So these files are now going to be in a folder with the DB extract name. And so when I switch to the folder view, we can see the CO and security folders there. CO is my primary schema. I can just drag those right into my SQL projects folder, and immediately they become part of that SQL project. So if I switch back into the solution view and load the project back, I can see I've got a folder for stored procedures and tables, and now I can build the project. This is going to go back through, and to nobody's surprise, the build is going to succeed because we know our syntax is valid. We know all of our relationships are valid because we just pulled this out of an actual database. All of these object definitions are declarative. There's no storing different alter scripts and things here. This is all create stored procedure, create table statements, and then I can modify them as is. The other thing is because I ran a build, I will have that build artifact, that DAC pack, in my debug folder. So I know that I have that, and I can use that if I need it down the road to start doing deployments. But before I start doing deployments, one of the big things that even if you're not using SQL projects for deployments, you can use it for source control on your database. And sometimes this is one of the biggest challenges that organizations have is they can't get their databases into source control to track changes over time. And so using SQL projects and extracting to them is one way to make sure you're managing your files that way. So what about the different IDEs? We've got two core places where SQL projects are available. I mentioned in that last demo, hey, I was using Visual Studio 17.12. Got to grab the latest. This is where the SDK-style SQL projects are available in preview. This is an ongoing effort, and right now, the recommendation is to only install SQL projects as a standalone feature in Visual Studio. There's so much overlap of dependencies between the original SQL projects and the SDK style that there's really some existing conflicts that we recommend you be able to avoid by having a separate instance of Visual Studio. This is not the end state. That's why it's still marked as in preview. And we're going to be continuing to develop and bring those SSDT features over to SDK-style SQL projects. And for VS Code, because the SDK-style SQL projects are cross-platform, there's the SQL Database Projects extension in VS Code, just like you can develop other .NET workloads in VS Code. The work in VS Code right now, you've got your project explorer, you've got a bunch of different templates for creating tables and different things. But we're working to build additional features into VS Code to make that more rich as well. And that includes the schema and compare functionality that's available in the original Visual Studio as well as in Azure Data Studio. So really making Visual Studio and VS Code pretty complete for SDK-style SQL projects as we move forward. We've brought a database into code in SQL Project, but the thing about when you're checking code in and when you're moving it forward, so let's say we have that SQL project and we maybe want to do some development because we've got time today. What do we worry about when we make changes to code? The first thing is it valid? And then the other thing is it good or even decent? We talk about code smells or code analysis, those kinds of concepts. When you work with Build, .NET Build, you're able to validate that your SQL syntax as well as the model integrity is correct. But SQL projects offer a couple other things to allow us to make our SQL development better. The first one is code analysis, so the analysis on the actual SQL that's used. By default, there's a couple rules included, which is nice, but you can also use package references in your SQL project to extend that code analysis to an additional set of rules. And these can be custom written rules. So there's community members that have contributed a ton of rules, and you can also write custom ones for your own organization based on the use cases that you have. The last thing that I want to highlight before we dive into the demo is when you're doing CI checks, it can be nice to use like mocking out or stubbing out database calls so that you can test your application code. With SQL projects, they can become part of your application unit testing if you consider using service containers. So you have this kind of ephemeral, kind of build it up, tear it down, throw it away endpoint for your databases with unit tests that you can deploy to really easily when you have your SQL project definition. So if we go back into Visual Studio, I'm going to consider making some changes. I'm not the world's best SQL developer, but I need to make a view that references all of the products. Now I'm naming this my select star view, and I'm going to select star from co.products. That's the table in my table folder. And I can build, and I managed to get all of my SQL syntax correct. So I'm feeling pretty good about it. But if I turn on code analysis, I can either use the property in the project file or I can use the command line flag. I can get more insights into, is my code really good? We knew it validated, but what does code analysis have to say? It turns out I probably shouldn't be using select star because it makes my result set change shape. If the columns in the table change, I can't control that view. So that was a nice reminder there. Let's start building some CI pipelines that tell us what's going on in our code before we check it in. So I can do that same run code analysis, but on the command line. So instead of having it in my SQL projects as a property, I can still put it on my command line. The other thing that I can do is I can use a package reference to extend the rule set. I talked about how there's just a few rules that are included by default. It caught my very gross mistake just a moment ago, but I want to extend that with one of the community libraries called tsql smells. So if I add that package reference to my SQL project file, then that's going to be included when my .NET Build runs code analysis just based on the name of the library and the version. So it's going to be able to pull that from any package feed that my build agent has access to. The other CI check that I want to have in place is going to use sidecar containers or a service container. It's going to grab one of the SQL Server containers. It's going to set it up with a randomized password I've got stored in secrets. And then I can run a deployment to it all immediately within the same pipeline. I could continue this pipeline with my application code to run unit tests, or I could even unit test the SQL itself. But that's my SqlPackage publish command that has that target connection string as well as the source of that build artifact in the debug folder we saw earlier. So I'm going to add those code analysis rules to my SQL project file on main. I haven't protected the main branch yet, but don't worry, we're going to move to a different branch to work on my view, just in case it's something we decide we don't like. So if I add my view, and commit that to my branch. Once I've published the branch, we get a PR opened on GitHub. I'm doing a lot of these demos in GitHub because that syntax is easiest to share more widely in the example repositories. But all of these concepts apply to Azure DevOps and other CI/CD environments. So through the magic of recorded demos, these CI checks are going to clean up pretty quickly, and we'll be able to see, is my code able to build and deploy, as well as does it pass that kind of is it good mentality of code analysis. And it looks like it's failing code analysis. We ran it locally, so we're not too surprised. But what's nice to see, in a sad way, is that the additional rules that I added to my SQL project file as a package reference are giving me additional warnings about code that was already in my database. So I had a stored procedure for add product image that I need to go clean up and take care of. The deployment itself, we know the build succeeds, so we would expect the deployment to also succeed, and it does. So it took just about a minute to go ahead and grab that container, stand it up, and deploy the SQL project all in that one fell swoop. So we're able to check if our code is valid, but is it good as well, just by adding some CI checks to our database. The thing that we touched on just a moment ago with using package references to extend code analysis are also part of the improvements for database references overall with the Microsoft.Build.Sql SDK. Original SQL projects have the concept of database references already, and they're limited to DAC-pack references and project references. Those still are both around, but we definitely would encourage you to consider using package references, because when you use a DAC-pack reference, when you're referencing another build artifact, you have to move that artifact around to all of your different environments, and then you're kind of having to reference files, and that's just a lot of copy pasting, a little bit more management than maybe you need. Package references, there's a little more setup, but you get the payoff of it being easier to manage. When considering why you might be using database references, think of this in terms of when you have a very large .NET project and you start to break it up into different classes, it's giving you a little bit more efficiency in terms of development, but there can also be some build time improvements. And the same thing is true for SQL projects, where if you have infrequently changing objects, maybe a schema in your database is managed by a completely different team. If you put that in a static package, it's not going to have to be rebuilt every time, and that will speed up your builds in a lot of cases. The same .NET pack command is used to convert a SQL project into a new package. And the kind of use cases for breaking out your database go beyond just a single database being broken out. If you're developing on SQL Server, where you might have three-part naming across different databases on the SQL Server, you can use database references, including package references as well. In fact, one of the most common cases for three-part naming is to access system databases. And for that reason, we've already published the system DAC packs for you to be able to reference. So let's take a look at a use case where we might be using a reference to a system database. So we will go back to main just to kind of play around with this concept. We'll let go of that select star view. Maybe that wasn't the best idea. So in my project, I know that I can build it. I know that I can get a DAC pack. And so when I expand out my artifacts folder under Contoso Outdoors, I can see the DAC pack. But if I want a package that I would be able to publish to a feed, either a private one or a public one, all I need is the .NET pack command. Just like your regular .NET projects, that also gives me a NuGet package here. And this contains the DAC pack inside of it. This contains that database model. So when I do a package reference, I'm able to add those objects in. What if I needed to reference additional objects? If I had a stored procedure that was looking for the active connections on a database, this would be referencing a view or a DMV in the master database. This is probably more of a use case for like a utility stored procedure that a DBA might expect to have on an instance to be able to troubleshoot with. But when I run .NET Build with this stored procedure in my project, I get a bunch of warnings. The SQL project tried to validate all those columns, session ID, client net address, and couldn't because it doesn't know what the contents of master are. That master database just is unknown. But if I'd add a package reference right off of NuGet.org, just like I would another .NET project, I can add that reference to the SQL 2022 master deck pack right to my project file. Once that's in place, if I do not .NET build again, I'll be able to verify whether or not all of those columns do indeed exist on that view. And in this case, we were able to do that validation. So I've been able to check again that kind of first category of, is it valid? Yes, I can confirm I've written the right SQL here. So it's been fun kind of making sure that we write code that is decent. But at the end of the day, decent or not, we need to be able to ship it. It's great to have all those CI gates in place to make sure that we're writing good code. But writing good code doesn't do us any good if we can't ship it. And this is where SQL projects really shine, because there's a whole kind of tooling ecosystem that enables us to do deployments. And sometimes we think of doing deployments as like clicking the button once and having it run, or we underappreciate the people that have to go run scripts to do deployments. But for SQL projects, if you have an environment where you scale up, where you scale out across multiple database instances, being able to have something that automatically finds out what the differences are by doing a model comparison. So when you run SqlPackage publish, or you use the publish option in Visual Studio or VS Code, it takes the DAC pack, it takes the build artifact as the source and connects to the target. The first thing it does is run a bunch of queries. So it's not modifying the target at all at this point, but it's just reverse engineering to understand what are the objects there and compares them at the model level. When I say at the model level, and then when we move on to looking at what the model differences are, I want to be really clear that this is really important to the ability to be able to generate a working deployment plan. Thinking of something in terms of a model and how the differences could have dependencies is really crucial, because if I have changes or differences in my model where I have a foreign key to be added and some columns to be added, if the foreign key uses the columns that need to be added, this is where it's great that the deployment plan that's generated will detect, hey, we need to add these columns before we can add the foreign key. After a deployment plan itself has been put together, the tooling gives you a script through script generation. The default option when you hit publish is script execution. I put a dotted line there because usually that makes some people nervous, where they're like, wow, something's going to modify my database automatically. That's so very untransparent. The good news is there's actually options here. You can do publish, which immediately publishes your project. That's appropriate for some environments, but not all. You can have SqlPackage give you the script for you to refine or to hand off to someone that knows SQL better than I do. And then kind of in the middle there is a really cool and sometimes underused option to generate a deployment report. It's not a PDF. It's not something you can email off. It's actually a bunch of XML, which is nice because then we can write automation based off it. So being able to kind of go environment by environment to do the deployments is a great use case. I'm going to hop through a really quick demo here where we've got a couple different pipelines. The first one is just the concept that we have a development environment, and this is the first of our 3 stages: dev, staging, prod. Anytime something gets pushed to main, we can run publish. We are going to gate main, so we know it's going through a PR. We know it's going to have code analysis run. We know the build's going to pass, so we can go ahead and run that publish. That's awesome. Now, what about staging? We can generate a deployment report on push such that when the push comes into main, we compare staging and main. But instead of having it do that publish, we'll have that deployment report generated. That deployment report is just a bunch of XML. So when we do get that XML, we're not stuck with just all of that gobbledygook. We can take it and process it and kind of do different actions based on it. If I was going to have additional manual steps to do a deployment to staging or to generate scripts for prod, I would want to have a really clear indicator whether or not there was an alert on the staging environment. So if I hop forward real quick, this is like the world's most basic bash script, and all it's doing is a quick little grep to find out, is there an alert element in the deployment port? If there is, it's going to exit code 1, which will fail my pipeline. So I get this really like clear blinking indicator that I have a failed pipeline. And so at the end of the day, with my deployment report, when it gets generated by that pipeline, the pipeline will fail if I have some kind of data movement, or I've added a column that's not null. It's warning me that I could have some data. So there's different scenarios that'll generate alerts, and this allows you to know when you do want to dig in further versus when you maybe just want to go ahead and have a deployment happen. There's a couple pipelines included in that sample repo. The first one is just the basic deploy to dev. The second one is the deployment report that gets generated. Both of those happen immediately on push to main. There's 2 additional pipelines that are manual interventions. In GitHub, the particular interface has you click run workflow. There's a couple different ways to manage that across different environments. But these are the kinds of tools that we would use to have more control, even beyond just a deployment report, on deploying to different environments. The one thing that I can't stress enough here is that you can have different levels of permissions across different environments. For our prod environment, to generate a deployment script, I don't need to have, my pipeline doesn't need to have execute permissions or really elevated permissions. I just have to be able to read the metadata on the database, and then I can hand that script off to someone, again, more knowledgeable. So in this case, when my prod environment workflow ends, I've got this artifact that's been saved, that deployment script that I can hand off to a DBA, and then I'm all set. So we've kind of iterated through a lot of topics all along the span of CI/CD built on top of SQL projects here really quickly in the last like 25 minutes. With Visual Studio and VS Code, you have development environments that are compatible with SQL projects. You've got GitHub and Azure DevOps tasks that enable you to not have to use SqlPackage directly, but you always have a SqlPackage CLI to use directly, just like we did in our examples today. Last but not least, the API surface area for SQL projects is called DACFX, DACFX, and that API is a .NET library. You can use that directly if you're so interested. What I knew I definitely wouldn't have time for today is talk about something that's a really big deal, which is the preview release of SSMS 21, SQL Server Management Studio. This is now in preview. It's gotten a huge upgrade from its movement on Visual Studio. So there's a blog post linked there, aka.ms/SSMS21 preview blog. In that screenshot of SSMS right there, there's 2 things. I'm going to mention the first one, and you can guess what the second one is. The first one is the introduction of source control back into SSMS. And this does mean that if you open up a SQL Projects folder in SSMS, you can kind of interact with source control as well as the developer console and use SQL Projects in a slightly different way than you would in Visual Studio. For the SQL Projects roadmap, I'm not going to drain this slide, but I do want to call out that we are not done. We have a lot of exciting stuff coming up this month with a release candidate about to come out, and then general availability in early 2025. I already mentioned how we're going to be continuing to move the development environments forward, with that being both Visual Studio and VS Code. So please, if you've been intrigued by the idea of having really rich CI/CD on top of your database, you can check out the documentation at aka.ms/SQL Projects, as well as all of those sample workflows that we use today, and even the sample SQL project is at SQL Projects-samples. Now, if this wasn't even your jam, you still already heard about all the great stuff in .NET 9, so grab that, and thank you so much for your time today.